Hey guys, it's Sims here. I wanted to give you some examples for day 2 since I'm not going to be with you in class. So if you're looking at the homework, I'm just going to go through the 2 examples that are at the top of the page, and then I'm going to pick a few more throughout that unit there and see which ones I want to work. So let's start off here with example 1. So this is day 2, solving rational equations. All right, so remember the steps. Again, I wrote them at the top of the paper, but it basically comes down to do your domain restrictions, find your lowest common denominator, multiply each term by the common denominator, cross out, do algebra, and then just check your solutions. So we're going to start off here with example 1, which was 3 over x minus 4 over 5x is equal to negative 11. So I'll start off with my restriction, x cannot equal, and then I go there, they cannot equal 0, but that also is 0, so because 5 times 0 is 0, so it's only there one time for me. So that is my only restriction. Now my LCD is a little interesting here, because if I look at the first fraction, I have an x, but the second is a 5x. So I actually need both factors. 5 times x will be my lowest common denominator. So then I will come to the fractions here, and I will multiply them by 5x. So I'll say 3 times 5x. I'll say 4 times 5x, and I'll do negative 11 times 5x. Just like that. So I cross out, and as I go to cross out, I'll cross out this single x with that single x. I'll cross out the 5x with the 5x, but there's nothing to cross out, so I won't have to worry about that one. So I'm going to say 3 times 5 minus 4 times, well, everything crossed out, so I'm just going to put a 1 there. And then over here I've got negative 11 times 5x. So then I'll go ahead and multiply. So 15 minus 4 equals negative 55x. And then that gives me 11 equals negative 55x. And y'all know me, I'm going to write that as negative 55x equals 11. I'll divide that by negative 55. And cross out, and I'll get x equals, let me erase that little straight mark right there, negative 1 over 5. Now, x equals negative 1 over 5 was not a restriction, so that will be my final answer. All right. Then next, I'm going to go ahead and work on my second problem. So in example 2, in example 2, we have x plus 3 divided by x squared minus 1 minus we have 2x times x minus 1, and we equal 1. So this is my problem in which I want to deal with the fact that I have this term, x squared minus 1, is not factored. So let me work on factoring that really quick here. Let me see if I can make my screen just a little bit bigger. Okay. So I'm going to write that as x minus 1 times x plus 1 because I really have dots right there. So now I know x cannot equal, and negative 1 and positive 1. Negative 1 for that factor, positive 1 for that one, and positive 1 for that one. And then as I go to get my LCD, since this first term has 2 factors, I'll write them both down. And then when I get to my second fraction, I realize, oh, I've already written x minus 1. There's no point in me writing it 2 times. So remember we said we only write it twice if we had a multiplicity, so that'd have to be a squared quantity. It's not squared. I don't have to write it. Then I'm going to multiply every term here. I'll do it kind of vertically. X minus 1, x plus 1, x minus 1, x plus 1, and even over here, x minus 1, x plus 1. So it's so important that every single term in your problem, 1, 2, 3, all get the common denominator. Little interlude right there. So I go and I start marking out. So in my first fraction, both the terms will mark out, and I'll just have x plus 3 minus, in my second fraction, I'll have the x minus 1, so I have 2x times x plus 1. And then in my last fraction, nothing's going to mark out, so I have x minus 1 times x plus 1. So definitely in this homework, more than we saw in yesterday's homework and yesterday's examples, or I guess it was Wednesday, it really wasn't yesterday, you're going to have a lot more algebra to deal with. So here we have to FOIL, here I have to distribute, and so let's go ahead and get started with that. That'll be x plus 3, and I'll distribute that. That'll be negative, equal sign, I don't really want there. That'll be negative 2x squared. And that'll be negative 2x. And over here, as I FOIL, I get x squared minus 1. Now, I know I didn't show the FOIL steps, but remember that x squared minus 1 and x squared and x plus 1, we got it from that first denominator right there. So I already knew that that was going to be x squared minus 1. So I need to work on bringing everything to one side. So I'm going to subtract x squared. I'm going to add 1, and then I'm not happy with how this looks because I didn't combine like terms yet. So I've got x plus 4, I've got negative 3x squared, and I've got negative 2 equals 0. So I realize, oh, I forgot to write the x right there. I realized that I have some like terms. I didn't put them together. So let's put those together. I really have negative 3x squared minus x plus 4 equals 0. Now, I could factor, but we don't really ever want to factor with a negative right here. So what I'm going to do is I'm just going to multiply through by a negative 1. Basically, I'm just going to change all the signs. Those look like multiplication symbols. So that becomes positive 3x squared. That becomes positive x, and that becomes minus 4 equals 0. So this is my trig factoring problem. When I say trig, it's the fact that I'm going to have to divide and multiply by 3 at the same time. So 3 times 4 is 12. So factors of 12 that give me a positive 1 would be positive 4 and negative 3. That was a negative 12. So positive 4 over 3, that doesn't reduce, so that would be 4x plus 3. And that does reduce to negative 1. So that gives me x minus 1 equals 0. And then as I solve, I get x equals negative 3 over 4, and x equals 1. So I'm ready to circle my answers, but I noticed, wait a minute, we said x cannot equal negative 1 in this problem right here. So that means I will only circle this problem because it's not in that list, and I'll mark that out. And this is our first real example where we see that extraneous solution. So remember, that's that solution that worked out with algebra, but didn't work out in the problem. So these are the first 2 examples I have. I am going to put a couple more problems up, but if you feel comfortable with these 2 examples, please go ahead and start on your assignment. Have a good day.